Hey all, today we are going to cover Module 1.2. We're going to talk about some characteristics of graphs. So we're going to look at some different graphs, figure out what they're telling us, draw some conclusions based on the information that we see. Our goals for today are to be able to identify the characteristics of a graph. We're going to talk about a couple of different things as far as a graph goes and being able to see what those are. We're also going to analyze a graph in order to draw some conclusions and even make some predictions. And we are going to do all of this from information that we are given on a graph. First of all, if we look at this graph, what is the domain and range? Remember that we talked about domain is all of the values that X covers or the width of the graph. Range is all of the values that Y covers or the height of the graph. So if we look at this one, when we're talking about domain here, and remember we're going to use interval notation, the domain is time. So we're starting at 0 time and we're going to 2.5 seconds. My graph starts at 0 and by 2.5 seconds, whatever is happening here is done. My range, remember, is from lowest to highest. So my lowest is clearly 0. Something is at a 0 height, meaning it's on the ground. It doesn't start at 0 though. Obviously it started about 100 feet in the air. Again, I don't know the situation here, but I'm going to assume that maybe somebody dropped something off of a roof or they were standing on a ladder. I don't know, 100 feet is a lot higher than a ladder. So somebody must have been on a roof or a cliff or something. They dropped it off and they timed how long it took to reach the bottom. Maybe they dropped something down a well or a hole in the ground or something. I don't know. But either way, they're starting at 0 as the top of that range, or 100, I'm sorry, is the top of that range, and 0 is the bottom of that range when it hits the ground, the bottom, whatever. And the domain of this is time, and it takes 2.5 seconds. So we're starting our time at 0 always, and we're going to 2.5 seconds, and that's when something hits the ground. Functions have intervals. So, and there's different types, okay? We can be increasing when something is rising from left to right. A function is decreasing for an interval when it falls from left to right. And you can see that there's also constant here. That's when it neither rises nor falls. It's staying constant from left to right. All right, so we've got a situation here. Lyme disease is a bacterial infection transmitted to humans from ticks. Gross. When an infected tick bites a human, the probability of transmission is a function of the time, since the tick attached itself, to the skin. The graph shows the probability of transmission. So looking at this graph, time is my domain. That's my X value. The probability of getting Lyme disease is my range. And notice that the probability or the range is from 0% to 100%, right? That's the percent probability of anything. You have somewhere between 0% and 100%. You can't have negative 4% chance of getting Lyme disease. You can't have 150% chance of getting Lyme disease. So the range is pretty static there. The domain is what kind of changes, is the time that it takes to increase your probability of getting this, okay? So we've got a couple of different intervals. We've got our first interval, it looks like from 0 to 24. So in the first 24 hours, the probability of getting Lyme disease from a tick bite is 0%. It is constant there, and the rate of change would be 0. Our second interval is from 24 to 48. So in the second day, second 24 hours, now this time we go up 10%. So the rate of change here is 10% over the course of one day. Our third interval is the third day from 48 to 72 hours, and you can see that there is a drastic increase there from 10% all the way up to 75%. So that is a 65% increase or rate of change over that third day. The fourth day isn't quite as drastic, but you are jumping from 75% up to, and not quite 100, let's call that like 98%. So 75 to 98% would be like 23% change. And then, of course, on the fourth day to the fifth day and probably on, you're about 100% likely. So that jumps about 2% there. When is a person most likely to be infected and how do you know? So looking at this graph, I would say that a person is most likely to be infected on the third day. How do I know that? Well, for the first 2 days, your chance of getting Lyme disease is 10%. It's 0% the first day, 10% the second day. So over the course of 48 hours, if you get the tick removed within 48 hours, you're only 10% likely to get Lyme disease. All of a sudden, if you let it go for another day, which is your interval, you're now 75% likely to get that Lyme disease. So I would say once that third day hits, all of a sudden it's almost guaranteed that you're going to get this. And from there it goes up. So I would say leaving a tick in for 3 days is when you're most likely going to be infected. That's lovely to think about, right? So it's important to check and make sure that you don't have any ticks, because obviously the probability of getting Lyme disease from it, which is super serious, increases drastically on your third interval, which in this case is the third day. I hope that kind of made sense for you. I hope that you can understand and can analyze some graphs here and pull some information. Don't forget, when you're looking at graphs, always read the title and what the y and x-axis are, okay? The titles of the graph and the axes will give you a ton of information and can often tell you a lot more about the graph than what you might see with just the numbers, okay? So always pay attention to the titles of both the graph itself as well as the two axes to see what's going on and what it's talking about. If you have any questions, as always, let us know. Shoot me an email or chat with me, and I would love to give you more information. Hope you have a fabulous day.